y'all. Oh wait, I just need to move that. Okay, so today, compare and order real numbers notes outline. So just drawing your attention to the word real numbers. We're talking about both rational and irrational. Rational and irrational numbers. Sorry about that. And we've worked with roots and estimating, and we've worked with rational and irrational numbers. And so now we're putting them all together and we're going to order and compare them. And so sometimes using a number line can be helpful when you want to compare order. And so I'm just going to kind of show you what would maybe be helpful to you. Sometimes the numbers will be displayed as a decimal, and you would find that number on a number line. So 2.9 would be close to 3, and then you would want to label it, what it is. And then negative 2 2/3. So I would say, because I just think because of money and that's easiest for us to see, decimals are easy to work with. If you have a really good visual conception of fractions and you know where negative 3 2/3 is on a number line, great. If not, change it to a decimal, and that would be negative 3.6 repeating. So negative 3, between negative 3 and negative 4, and a little bit closer to 4 because it's 0.6, so it's a little bit more than half. So negative 3.6 repeating. And then the square root of 5, you learned how to estimate square roots. And so the square root of 5 would be between the square root of 4 and the square root of 9. Right? It's between those two perfect squares. And it's going to be more than 2 because the square root of 4 is 2. So it's going to be between 2 and 3. But because 5 is closer to 4, this number is going to be closer to 2. So we could say like 2.1 or 2.2. Now, I'm not going into like a lot of the math behind it. If I wanted to, I could say square root of 5 is between 4 and 9. And then I would subtract from here to here, and that's 1. And then I would subtract from here to here, 9 minus 5, and that's 5, which would be 0.2. So really, it should be 2.2. But it just helps us kind of understand where on the number line these numbers fall, because they're not always going to be written the same way, meaning all decimals, all fractions. So use what you know, your prior knowledge of estimating roots, and put them on a number line to help you. So example 1, compare using less than, greater than, or equal to make a true statement. So I have two values listed, square root of 7 and 2 2/3. Now I know that 2 2/3 is 2.6 repeating because 2/3 is 0.6 repeating. And if you divided 3 into 2, you would get 0.6 repeating because it's always going to be 20, 18, 20, 18, 20, 18. Now, square root of 7 is going to be between 4 and 9, the square root of 4 and the square root of 9. It's going to be between the square root of 4 and the square root of 9. So it's going to be 2 point something, right? Because the square root of 4 is 2. 7 is 3 away from 4. And 4 and 9 is 5 away. You can't see what I'm doing. 3/5, which is 0.6. So again, I have 2.6. So because this is 2.66 repeating, this is going to be bigger than the square root of 7, which is just 2.6 estimated. All right. Another example that I want to show you what to do when you have a square root is we could square this. Because do you remember what happens when you square a square root? When you square a square root, those cancel, and we're left with just 7. Okay, I'm just going to put a 7 down here. And now we would need to square this side. 2 2/3 times 2 2/3. So I'm going to come over here, and 2 2/3, I'm going to change to an improper fraction, which is 6 8/3. And then I'm going to square it. And I'm going to get 64 divided by 9. So 64 divided by 9. Okay, are you with me? Well, 9 will go into 64 7 times. 7 times 9 is 63, and I'm going to have 1 left over. So I know it's going to be 7 point something. So I still know that this side is bigger. 2 2/3 is bigger. So whenever you have a square root, you can always square it to cancel the square root out if you don't want to estimate. Like 7.1 or something. All right, that's just another example. All right, B. 18 over 5 and pi. Well, I know pi is about 3.14 because we've been taught to round pi. And I need to divide 5 into 18. Well, it'll go into it 3 times. And then I need to add my decimal, bring down a 0. 5 will go into 36 times. So this is about 3.6, and this is about 3.14. So 18 over 5 would be bigger, greater than. All right, C. I'm comparing 1.5 to the square root of 225. Now, if you know, 2.25. If you know the square root of 225, like whole numbers, then this one would be very simple for you because you can get it. If not, I would recommend squaring both sides. If you square, the square root and the square cancel out, and I'm left with 2.25. And then I need to come over here and I need to square 1.5 times 1.5. So we multiply 5 times 5 is 25. 5 times 1 is 5 plus 2 is 7. Your 0 placeholder. 1 times 5 is 5. 1 times 1 is 1. I add these up. And I have 2 decimal places, so I move it over twice. And I get 2.25. So it turns out that these are equal. Now, if you knew the square root of 2.25 because you knew 225, then you would have known that this was the square root is 1.5. So you could have known that those were equal a while ago. But I wanted to show you how to square, and then when you square it, they cancel each other out. Okay, you tried D, square root of 11 and 3 1/3. So you can either estimate the square root of 11, or you can just go ahead and square it and then square this side. So press pause and you try D and you try E, and then I'll show you how. Okay, so I'm going to square both sides. And those cancel, and I'm left with 11. 3 1/3 would be 10 over 3, which is 100 over 9. And when I divide 100 divided by 9, I'd get 11 point something. So the answer would be less than, because I know it's going to be 9 with a remainder of 1, and then I'm going to add another 0. And so it's going to be 11 point something. So that would be bigger. All right, you try E. Square root of 17 and 4.03. Again, I would square, so I'm left with 17. And I would square that. Actually, this is 3 digits. I don't really want to square 3 digits because that's a lot of multiplication. So maybe it would just be easier to estimate. This is going to be between the square root of 16 and the square root of 25. And so it's going to be because it's between 4 and 5, it's going to be 4 point something. There's 1 digit difference between 17 and 16. And then there's 9 digits, which is 0.1 repeating. 1 over 9, we've already reviewed repeating decimals, 0.1 repeating. This is 4.03, so square root of 17 is going to be larger. Okay. Whew. So a lot of comparing. And now order each set from least to greatest. From least to greatest. So in A, I have the square root of 30, 6, 5 4/5, and 5.36 repeating. So again, my recommendation is to turn them all to decimals. I have 2 already done, and then 5 4/5. If you don't know what 4/5 is, you come over here and you divide 5 into 4, and that is going to be 8. So this is 5.8, 5.36 repeating, 6, and then the square root of 30. So square root of 30 is where we need to use our estimating rules that we just learned. And I know it's going to be between 25 and 36. So it's going to be 5 point something because it's between 5 and 6. There's a difference of 5 here, and then there's a difference of 11. So 5 elevenths. Now, you can divide 11 into 5, but I know I mean, I'm a math teacher, but I see if I can make this equal 99, then I know I'm going to have a repeating decimal, which we've been working with. So what can I do from 11 times what to get to 99? And hopefully you're seeing, oh, well, you times 9. And then on the top, I would times 9. 5 times 9 is 45. So I know because the denominator is 99, this is going to be 45 repeating. Now, this is just my estimate. Just my estimate. If you want a calculator and actually calculate the square root of 30, it's not going to be 0.45 repeating. It's just an estimate. But this gives us enough that we can order the numbers from least to greatest. So the smallest one up here would be 5.3 with just the 6 repeating. And then the square root of 30, always use your original. Always use your original number. After the square root of 30 would be 5 4/5. And then 6 would be our final answer. Okay? So now let's do B together. B's are all negative. So remember when you have negatives, you're going to think differently. I already have 5.5 negative 4.5 repeating and negative 4. So let's go ahead and change negative 31 over 6 into a decimal. That's going to be 5. 6 will go into 10 one time. 6 will go into 40 6 times. And then I'm going to keep having 36, 40, 36, 40, I guess. 36, and then I'm going to do 6 again. But, so that gives us a good estimate, 5.16. No. Yeah, 5.16. Negative 5.16. And then I have the negative root of 25. Well, the negative root of 25 is just negative 5. So again, from least to greatest with negative numbers, I want to start with the biggest negative because really that's the smallest number. So that would be negative 31 over 6 is the smallest value. And then the negative root 25. And then between these two, do you know which one is the smallest? The smallest value is actually the bigger negative. So negative 4.5 repeating. And then negative 4 is actually the smallest, the greatest of the smallest. It's the biggest of the smallest numbers that we have. Whew, that was a lot. All right, last one. On Wednesday, there is an 83 1/3% chance that it's going to rain. On Thursday, there is a 90% chance it's going to rain. On Friday, there's a 6 out of 7 chance that it will rain. On which day is there a greatest chance? So let's circle the word greatest because that's the most important. Again, let's change them all to decimals. So 83 1/3% is 83.3 repeating. And as a decimal, that would be 0.8333, and the 3 is repeating. 90% is easy. That can just be 0.99 or 0.90. And then 6 out of 7 means we need to divide. Remember, the numerator goes into the division house. You add your decimal and 0. 7 into 60 would be 7 times. 49. Again, we have 11 left over. No. 8 times. Math off. That's too many to have over. So you would have 8 times. 8 times 7 is 56. Oh, that's better. We have 4 left over. See, that's how you know when you're wrong. If you have 11 left over, that's way too many. Bring down your 0. Now, I cannot just stop at 0.8 because I already have a 0.8. So I need to see where this compares in the hundredths place. 7 will go into 45 times. That's 35. And we're left with 5. So I have 0.85. And I've done enough now that I can compare the decimals. I have 0.83 repeating, 0.85, and 0.9. So on which day has the greatest chance of rain? That would be whatever was 90%. So Thursday has the greatest chance of rain. Thursday has the greatest chance of rain. And if you see on my work, I had to do some work to get that. But all of this is work without a calculator. And I would expect you to do all this work. So I think that is, just checking to make sure that I did all the examples that you needed today. And then Thursday is the greatest. Yep, okay. I was just looking to see all the examples. All right, we will practice more in class. Let me see if I can turn it on.